Greetings class, I hope I find you well. Right, we are now moving on to question number 11. It reads, the function f is defined by f of x is equals to x squared minus 4x, where x is an element of real numbers. Right, sketch the graph of f of x showing the intercepts and the turning points, 3 marks. We need to find the intercepts first, right? So we are given f of x is equals to x squared minus 4x, something like this. So I'm going to prepare a table of values to find the intercepts. So the intercepts, we need the value of f of x when x is 0. We also need the values of x when f of x is 0, of which the values of x, we are going to have 2 values of x since this is a quadratic expression or a quadratic function. I hope you are following. Right, so the first value, I'm going to obtain it by substituting 0 on x to find the corresponding value of f of x when x is 0. I hope you are listening, class. So you get 0 squared minus 4 open bracket 0, which gives you 0. So it simply means f of x is equals to 0 when x is 0. So this becomes your first intercept, 0, 0. I hope you are following. Then to find other intercepts, I'm going to put 0 on f of x so that we know the values of x when f of x is 0. So you get 0 is equals to x squared minus 4x, something like this. Then you need to factorize on the right side by factoring out x as the highest common factor. X into x squared, you get x. X into minus 4x, you get minus 4. So whenever you have 2 terms or 2 expressions multiplying each other, giving you a product of 0, it means one of those terms is also 0. So you get 2 equations here. You are saying x is equals to 0 or x minus 4 is equals to 0. So the first one is solved already. Then to completely solve the other one, you move minus 4 to the right side, you get x is equals to 4. So it simply means when f of x is 0, you also get x is equals to 0, and you also get x is equals to 4. These are the intercepts. I hope you are following. So let us put the intercepts on our graph or our Cartesian plane. So our Cartesian plane, we are going to have f of x, which is good as the y-axis. I hope you are following, class. Then you also need to have the x-axis, something like this. So the first intercept is the origin itself. I'm going to put a star here. Then the next point is 4, 0. Right? So where is 4, 0? If this is 4 for x, it means this point is 4, 0. Something like this. I hope you are following. Right, we now need to find the turning points of the graph. So turning points are found in 2 ways. It's either you are saying at turning point, dy dx is equals to 0. So you simply find the derivative of x squared minus 4x, then you equate it to 0. So derivative of x squared is 2x. Derivative of minus 4x, you get minus 4. Then equate this 2 to 0. You get 2x is equals to 4. Divide both sides by 2. You get x is equals to 2. This is the x coordinate of the turning point. I hope you are following. So to find the y or the f of x coordinate, you simply substitute x is equals to 2 in the original function. So you get 2 squared minus 4 open bracket 2. 2 squared you get 4. 4 times 2 you get 8. And 4 minus 8, it gives you minus 4. So the turning point is 2 and minus 4. I hope you are following. Another way to find the turning point is to use completing the square method. So you are saying x squared minus 4. Applying completing the square method, you add with the half coefficient of x, provided the coefficient of x squared is 1. So half of minus 4 is minus 2. So you are saying minus 2 squared, then you less the same minus 2 squared again. So from x squared up to minus 2, you get this bracket, x minus 2 squared. Then minus 2 squared is 4. I hope you are following. So the value of x, which makes x minus 2 squared to become 0, is 2, which is the x coordinate of the turning point. Then this minus 4 becomes the y coordinate of the turning point. So you still get the same answer as with differentiation. I hope you are following. So let us plot 2 and minus 4, right? So 2 is between 0 and 4. Let's say this is minus 4 here. Let's say this is minus 4 and this is 2 here. Where 2 and minus 4 are going to meet, we are going to have our turning point. So this is the turning point. I hope you are following. So our graph is a parabola. It is bell-shaped. It is symmetrical. So when drawing this, you need to create a bell-shaped graph, which is symmetrical. So this is how you sketch the f of x graph. I hope you are following. Let us move on to part B of the question. It reads, state the range of f of x. So the range is very simple. You can even obtain it from the graph. You can notice that the values of y are starting from minus 4 upwards. They are starting from minus 4 moving in an upward direction. So the range is simply f of x is greater than or equal to minus 4. So what is range? Range represents the values of f of x or the values of y, which makes the function valid. So below minus 4, we do not have the values of y, which are part of the graph. So the values of y, which are part of the graph, they are starting from minus 4 upwards. So your range is f of x is greater than or equal to minus 4. I hope you are following. And after completing the square, this minus 4 is used to identify the range of a quadratic graph. I hope you are following. But it simply depends with the nature of the graph. Is it a maximum graph? Is it a minimum graph? This one is a minimum graph because it is U-shaped. But if the coefficient of x squared was negative, we are going to have a graph which faces downwards. So for such graph, you then say f of x is less than or equal to the number that you get here after completing the square. I hope you are following. Right, let us move on to the question. It reads, if f of x is a one-to-one function, set the value of k 1 mark. Right. So for the quadratic graph to be a one-to-one, it means the graph is splitted into 2 using the line of symmetry. I hope you are following. So it means if you have 2 and minus 4 here, I hope you are following. The values of x will then start from 2 moving in n using this direction. So you are simply saying x is greater than or equal to 2 for the graph to be a one-to-one. I hope you are following. So what is a one-to-one graph? Remember, a quadratic which is not splitted into 2, it normally gives 2 solutions. At the point of intersection between the line in the graph, you get the solutions. I hope you are following. Right, so this number here on the line of symmetry is 2. So since they are saying x is greater than or equal to k, they need you to give the value of k, which start from the line of symmetry moving to the right direction. So the value of k becomes 2. So x is greater than or equal to 2. It becomes a one-to-one function. Why? Because we then ignore this part of the graph here. We then ignore this part of the graph here. So it means if we draw any line, it cuts this red curve once and not twice, giving one solution. I hope you are following. So our answer is x is greater than or equal to 2. Hence, in simple terms, we are saying k is equal to 2. Let us move on to part C of the question. Using this value of k, find the inverse of f of x stating its domain. So to find the inverse, you will simply complete the square. You are given f of x is equal to x squared minus 4x, right? Represent f of x with y. Then after completing the square, we got x minus 2 squared minus 4, something like this. I hope you are following, right? So how do you find the inverse? You make x the subject of the formula first. So you move minus 4 to the left. You get y plus 4 is equals to x squared minus 2 squared, something like this. Then using extraction of roots, to get rid of the power 2, you need to put square root both sides. But this time you are not putting plus or minus since it is a one-to-one function. So you now have square root of y plus 4 is equals to x minus 2, something like this. Then moving minus 2 to the right, to the left, you get square root of y plus 4 plus 2 is equals to x. So the inverse is found by replacing x with y with x. So we use this left part, right? Then on y, put back x to find the inverse. Therefore, your inverse becomes square root of x plus 4 plus 2, and this is your final answer. I hope you are listening, right? Then they are saying, stating its domain, 3 marks. So remember, domain is the range of values of x which makes the function valid. Right, so what is the property of a root sign? We must not have a negative number in a root sign. So for this to be valid, it means the component inside the square root, which is x plus 4, must be always greater than 0. We do not accept x plus 4 to be negative for the function to be valid. So moving 4 to the right, you get x is greater than minus 4. And x greater than minus 4 is your domain. I hope you are following, class.